All right, we're going to talk about the first derivative test today. And the first derivative test is a test to figure out where is the function. We're going to answer this question: how do you tell when a function is increasing or decreasing? And it will also help us find minimums and maximums. So when you look at a function, I'm going to just mark on here where it's increasing and decreasing. So this one starts out decreasing, and then it increases, and then it decreases, and then it increases. So we've got two spots where it's increasing and two spots where it's decreasing. Now if you look at what it has in common on the increasing parts of the graph, if you look at a few slopes of tangents on the increasing parts of the graph, you'll notice that they're always positive. Positive slopes of tangents mean the graph is increasing. Versus if you look at the decreasing parts of the graph, you have these negative lines. So negative slopes of tangents would be decreasing. So how I would summarize that is I would say if you have a positive slope of a tangent, or if the f prime, or the derivative, is positive, it's increasing. Here these are positive, so the derivative is positive, you're increasing. When you have these decreasing sections, the derivative is negative, or the derivative is less than 0. I'm going to summarize that down here. So another thing we see here is here we have a minimum, here we have a maximum, here we have a minimum. Minimums happen when you have a decreasing graph that switches to increasing. Decreasing to increasing. If you're going to have a max, you're going to have a graph that goes from increasing to decreasing. So we'll do a few fill in the blanks, and then I have an extra thing to add at the bottom here. So how do you tell if it's increasing or decreasing? First of all, this only works on intervals where the function is continuous and differentiable. And here's the deal. If you have a derivative that is positive, okay, positive, or greater than 0, and that's up here. If you have a positive derivative, then the function is increasing. Okay, now I'll say the other part of that. If you have a derivative that is negative, less than 0, here and here, that means your slope of your tangent is negative. Then f has to be decreasing. And the other thing is, sometimes it's decreasing faster, and sometimes it's decreasing slower, but it's always decreasing. So it is consistent throughout this whole time. Always decreasing, always negative derivative. All right? So if we look on this graph, here we have an increasing part. That would be a positive derivative. Here we have an increasing part. That would be a positive derivative. Okay. Then we have a negative part, or a decreasing. That would be less than 0. And here we have a decreasing, and that would be less than 0. The last part of the test is knowing if it's a min or max. So mins or maxes will happen when you have a change in direction. So if increasing changes to decreasing at a critical number, then what is it? If you go from increasing to decreasing, then it would be a max value. If you have that decrease change to increase at a critical number, we learned about critical numbers on Monday. If you go decreasing to increasing, then you have a min. And that's because you go down and then up, so that would create a minimum. Sometimes you'll have where it will go like increasing to increasing, or decreasing to decreasing, that's no change, and then there'd be nothing there. You know, no min or max if you see no change in direction.